Hello again, this is Rodolfo Eric Angat, your teacher in Earth and Environmental Science. Today we'll be learning about the Pacific Ring of Fire. Our essential question for today's lesson is, where are most of the volcanoes found? And with this, we aim to accomplish the following competencies. I can explain why earthquakes are common in the Pacific Ring of Fire. I can explain why the oceanic crust subducts, or it's the one that sinks during the convergence of two tectonic plates. I can explain why there are so many volcanoes around the Pacific Ocean. I can differentiate lava flow from lahar. I can describe the dangers of volcanic eruptions and earthquakes. And finally, I can suggest ways on how to alleviate the effects of geohazards. The Pacific Ring of Fire is also referred to as the Circum-Pacific Belt. So this is the Pacific Ring of Fire right here. So it runs like a U shape around the Pacific Ocean. The United States is right here. Now, North Carolina, which is here, is not within the Pacific Ring of Fire. That is why we do not experience a lot of earthquakes. We do experience some, but not as much as the places that are within the Pacific Ring of Fire, or also known as the Circum-Pacific Belt. This here is the Pacific Ring of Fire, and you will see that it has a lot of red dots. These red dots are actually volcanoes. There are a lot of volcanoes around the Pacific Ocean because in these areas around the Pacific, there is a lot of subduction. The oceanic plate is sinking underneath the continental plate. Or even when two oceanic plates are colliding, one of them sinks into the mantle, and the melted oceanic plate produce all of these volcanoes. See how many red dots there are around the Pacific Ocean? My country is right here, the Philippines. And then it goes around and around and around to Canada, and then to the United States. Right here, we have the San Andreas Fault. So this is a transform boundary right here. And then we have a lot of volcanoes again in Mexico and then in South America. There are different types of plate boundaries on Earth. And in our last discussion, we identified these lines here as the plate boundaries, and the one enclosed by these lines are the tectonic plates. So this is the tectonic plate of the North American plate. This is the tectonic plate of the Eurasian plate. Now the lines again are the plate boundaries, and there are three types of plate boundaries. Let's begin with the divergent. These two tectonic plates here are moving away from each other. The Nazca plate and the Pacific plate are moving away from each other, and that's divergent. Here we have another one that runs across the Atlantic Ocean, and this is what is causing the sea floor spreading. This divergent boundary is causing the Atlantic Ocean to become wider. That's why Africa is moving away from the United States because of this divergent boundary. Another one, we have a convergent boundary right here. So this convergent boundary is causing the subduction. And then we have the transform or strike slip, which is the reason why we have the San Andreas Fault. Then we have the convergent there. So these are the convergent boundaries right here. These are convergent boundaries, and there are a lot of volcanoes in convergent boundaries because the oceanic plate is sinking and it's melting in the mantle. And that melted plate is the one that rises up, that rises and form the volcanoes. Okay, that's also a convergent. And all of this circle here denotes the occurrence of earthquakes. More than 90% of all the earthquakes that happen on Earth happen within the Pacific Ring of Fire. And that's why when you are asked, where do most earthquakes happen? The answer there is they happen in the Pacific Ring of Fire. So if you are living within the Pacific Ring of Fire, then I'm sure you are very familiar with earthquakes. 90% of earthquakes happen within the Pacific Ring of Fire, or even higher. The Ring of Fire is home to 75% of the world's volcanoes. Imagine that. So 75% of all the volcanoes on Earth are around the Pacific Ring of Fire. So that's subductions happening there. And of course, there are a lot of volcanoes here because there is subduction. And subduction is a result of a convergent boundary. And those are the volcanoes. Here we have a transform boundary, and this one results to a strike slip fault, which is known to us as the San Andreas Fault. So why do the oceanic plate subduct or sink, subducts or sinks under the continental plate? You will see here that the oceanic plate is subducting. You can also call it as the oceanic crust. This is the continental plate or the continental crust. The oceanic plate is subducting because the oceanic plate is denser. It's a lot heavier with the same amount of uh, material in it. So, though the continental plate is a lot thicker than the oceanic plate is a lot denser. That's why it sinks or it subducts. When it reaches the mantle, it melts and some of the magma rises because magma is less dense and goes to the surface and form a volcano. Volcanoes can also form underneath the ocean. Okay, so volcanoes are not only found on land, they are also found at the bottom of the ocean. Now, you'll notice here that this is the continental crust, and you have here the rising magma that forms the volcano. Here, we have the oceanic crust, and it's the one that is subducting. Remember that subduction happens in convergent boundaries. Oceanic crust is subducting. Oceanic crust reaches the mantle and melts and become magma. This magma, being less dense, rises to the surface and becomes a volcano. Now, this area here is what we call as the Benioff zone. This Benioff zone is an area where earthquakes happen. This is the main reason why we have a lot of earthquakes along the Pacific Ring of Fire. The sinking oceanic plate causes friction with the continental plate or continental crust. The friction of the two is the area where we call as the Benioff zone, and that friction sometimes it just locks and then the stress builds up, and when the rocks can no longer withstand the stress, they break. And when they break, that is when the earthquakes happen. That's when the earthquake happened. So this is the Benioff zone right here. Now, if it is a shallow one, it's close to the surface, then that's a very, very strong earthquake. However, if it is a deep focus earthquake, like it happens right here, then it would not be a very strong earthquake because it's too far from the surface. Shallow focus earthquakes are more dangerous. than the deep focus earthquakes. Okay, now look at this one. This is Mount Vesuvius in Italy. Okay, see how it exploded? Wow, that's very frightening. When Mount Vesuvius erupted in the summer of AD 79, the nearby Roman town of Pompeii was buried under several feet of ash and rock. The ruined city remained frozen in time until it was discovered by a surveying engineer in 1748. And this is what they found. The human beings who were caught by the pyroclastic cloud were preserved in their form. They were burned alive by the pyroclastic material. Let's look at this video, short video, to give us an idea what a pyroclastic material is. See, that's pyroclastic material right there. This is pyroclastic cloud, and this is really, really very hot.
The eruption attracted the attention of scientists and press. But one group made a fatal mistake when they headed into the exclusion zone and got caught in the path of a pyroclastic flow.
Again, this is pyroclastic material. When it is flowing on the slope, it's called pyroclastic flow, and it is very hot, and there's no way for you to outrun it because it's really very fast.
As superheated gases burn their lungs. The Pacific Ocean. This chain is called the Ring of Fire. The volcanoes occur above subduction zones, where submerged oceanic plates dive under continental land masses.
Okay, so those are the pyroclastic materials. Volcanic eruption can also result to earthquakes, pyroclastic clouds, lava, and lahar. I know you're only familiar with lava, but you should also know the pyroclastic clouds because these are most dangerous. This lahar is also very dangerous because it always comes when it is unexpected. That's why so many people are killed by lahar. Oh, by the way, this is my country right here. This is the Philippines. And we also have a lot of volcanoes. Let's continue. Now, earthquakes are caused by sudden slip on a fault. Earthquakes are most common in the Pacific Ring of Fire. Let's see this video.
Just last month, a magnitude 6.3 earthquake destroyed sections of Christchurch, New Zealand. More than 100 people died. 1 year before that, an 8.8 trembler struck Chile. More than 500 died. Today's massive earthquake off the coast of Japan registered a massive 8.9. Though separated by thousands of miles, each of these quakes occurred on the Ring of Fire, a 25,000-mile line along the Pacific Rim that is the most geologically active place on the planet, with more than 450 volcanoes. Most of the world's earthquakes occur along this line. The culprit, the Pacific Plate. The floor beneath the ocean is constantly shifting.
It's a very large system.
It's trying to make itself earthquake-proof. Today's video showed buildings in Shinjuku swaying but not collapsing. The U.S. has started to install shock absorbers under buildings as well, but has some catching up to do.
Nobody's ever prepared for this kind of earthquake, but compared to Japan, probably we're not nearly as prepared as Japan.
Scientists say Alaska and the Pacific Northwest are the most vulnerable to an earthquake comparable to the one that struck Japan today. Along the Ring of Fire, it's only a matter of time.
Okay. The Pacific Ring of Fire presents a lot of dangers to the countries that are along its path. Japan is along the Pacific Ring of Fire, and Japan experienced a lot of earthquakes. That is why they built their buildings with shock absorbers in their foundation. Here in North Carolina, we don't need to put those shock absorbers as of yet because we do not have an active fault line here in North Carolina. We do have some fault lines that run across to the west, but then they are not as active as the one in Japan because we are not in the Pacific Ring of Fire. However, in those areas, they really need to put shock absorbers on their buildings so that they can withstand the tremors that are brought upon by these earthquakes. Now, aside from earthquakes, lava, and pyroclastic material, we also have these things here. We have landslide, mudslide, slump, creep, and lahar. These are all erosion. They all happen because of one thing. They happen because of gravity. But lahar is not made up of just soil. It is mainly volcanic ash. So the one on the left is a landslide, while the one on the right is lahar. Landslide happen due to gravity, while lahar is a type of mud flow composed of materials from volcanic eruption. Lahar also flows due to gravity. The the sand-like material from the volcano is very hard when it is dry, but when it rains, this very hard lahar can turn into like very rapidly moving mud, which we call as the lahar flow. It moves so fast and it's so heavy, and it usually buries cities and towns along the path, and it's very dangerous. So here again, this is lahar, and this is a landslide here. The Hawaiian Islands and volcanoes were formed and are still forming because of hotspots. Unlike the plate boundaries, these hotspots are not actually plates that are interacting with each other. These hotspots are happening because the plates are moving and they are very weak. So the magma in the mantle easily penetrates these very weak plates that the magma rises up to the surface and forms the ocean. And this is the reason why the Hawaiian Islands are becoming longer and longer, because as the plates move, the magma rises, new islands are formed in the middle of the Pacific Ocean. These are called hotspots. The magma rises from the mantle, and the magma penetrates the weak plates. And from that, the magma becomes lava, and then the lava forms the volcanoes that form the islands of Hawaii. Now, let's talk about the effects of volcanic eruptions. The effects of volcanic eruptions can be divided into primary and secondary effects. The primary effects are immediate and come from the eruption itself, whereas the secondary effects result from the primary effects. So, of course, the primary effect would be the pyroclastic material right here and the lava, and then the secondary effect would be the lahar. Earthquake can also be considered as primary effect. Now, this is another video showing us the pyroclastic material flowing on the slope of the volcano. Ooh, that's very scary, isn't it? Okay. I do not know if they survived this, but I doubt they did. It's just too close to them. But we'll be learning more about the story of this pyroclastic cloud later on. So this one is called the pyroclastic flow because it's flowing on the slope of the volcano and it's really very hot. Now this one is showing us again lahar. Lahar is also from volcanic eruption, and it is a secondary effect because what happens is after the volcanic eruption, this sand-like material or mud-like material becomes so hard and so solid when it's dry, and when it rains, it rampages into a very destructive mud flow. And lahar usually affect the nearby towns and cities of where the eruption happened for more than 5 years. Imagine that. 5 years after the volcanic eruption, lahar is still on its slope, and until all of that lahar material goes down, then the danger will always be there. Again, when it is dry, it's very hard, but when it gets wet, it becomes a very, very deadly mud flow. Now, this is lava right here. It's a primary effect. Of course, this is what we are all familiar with, but actually, lava is very predictable in most cases, that is. So people can easily do something about it, like they can go, they can evacuate. But lahar, it's so dangerous because it has been 5 years since the eruption and it's still doing damage to the nearby towns and cities. So people are restless when there are still this volcanic material on the slope of the volcano, because whenever it rains, it can always flow down into their homes. So again, this is lava flow. The biggest earthquake ever recorded was magnitude 9.5. It occurred in Chile, where the Nazca Plate subducts under the South American Plate. Again, Chile is within the Pacific Ring of Fire. There is no theoretical limit to the magnitude of an earthquake, although it is estimated that an earthquake of magnitude 11 would split the earth into two. Whoa, I hope that doesn't happen. Again, this is the Pacific Ring of Fire. There are a lot of volcanoes there. And Earth is divided into different tectonic plates. And where the tectonic plates interact with one another, we call those the plate boundaries that come in three types: convergent, divergent, and transform. And Chile is right here. Okay. Now, let's talk about subduction. Again, subduction happens in convergent boundaries. This is a convergent boundary here because they're coming together. This is the subduction right here. This is the Benioff zone. The Benioff zone is where the subducting oceanic plate interacts with the continental plate, producing stress because of the friction between the two plates. That friction and that leads to stress results to earthquakes. Where the earthquakes originated, that's what we call as hypocenter or focus. Now, directly above the focus, that would be the epicenter, which we'll be learning as we progress. Now, that covers our lesson about the Pacific Ring of Fire. I hope with this, you'll be able to get a good grade in our MC assessment. Thank you so much, guys.